Today we will talk about correlation and regression. The first topic we will cover is linear regression, to fit data into a line. When you want to do that, what you're after is to come up with a regression equation that has this form: y hat equals b0 plus b1x, where your x is your the independent variable, and y is your dependent variable. Let's assume I want to find the best predicted time of the interval after an eruption, given that the current eruption has a height of, let's change this one to 130 feet. And this is the data given. Let's say we are talking about Old Faithful, and these are the heights in feet, and these are the time in minutes. Now, to be able to come up with the linear regression equation, you have to decide which one is going to be your independent variable. We are going to assume the height is going to be your independent variable, and the interval of time is going to be the dependent variable. So given the height, I'm trying to find out the interval of time in minutes of eruptions. So let's go enter the data. You go to Stat, Edit, and enter the X, the height, 140, 110, 125, 120, 140, 120, 125, and 150. And you go and enter your dependent variable, 85, 65, 72, 75, 83, 78, 80, and 92. What you need to do is you need to go and push Stat, Test, and for that one you need to get Linear Regression T-Test. Pick that option by pushing Enter. Your X less than L1, Y less than L2. Your hypothesis testing, the H1 is going to be not equal to 0. That means there is no linear correlation. And you push Calculate. That will give you the linear regression equation A plus BX, and it will give you the p-value. As you see, the p-value is very small, and it will be a lot smaller than any alpha that you pick. That's reasonable. That means you reject H-null. H-null is the, there's no regression, there's no correlation assumption. And on top of that, it will spit out a couple of numbers, A and B, and that means A is 4.1 right here, and B is 0.58x. When you scroll down, you get some other correlation parameters, like this one. The correlation coefficient is around 93%. That tells you that's a good correlation. Now, once you have the regression equation, you can also go and get the predicted y value given the x. To be able to do that, let's look at our graph. If you want to graph it, you have to go to Second Stat Plot and turn the plot on. And for that one, you need to pick the scatter plot and put your x less than L1, y less than L2. On top of that, you can also put your equation. To get the equation, you push y, and you enter 4.1 plus 0.58 times x, and x, you have to get it from this button. Then if you want to graph all this on your graphing calculator, all you have to do is push Graph, and it will give you the linear regression equation, the line itself, and the scattered plot of the data. If you want to get the value of x equals 130, what you can do, you can just put in 130 in here and predict y, or you can use your calculator and go and pick Second Calculate and pick the value, and X will be asked, then you have to enter 130 and push enter, and it will spit out the value, and it will show you where that is, Y of 79.5.